It's pretty grokkable. It's pretty grepable, son. Hey, Matt.
Hey, Mike.
Would you like to do a podcast?
I would.
Then let's do a podcast.
Okay.
Okay. Hello and welcome to Hacking the Grepson, the podcast where the two hosts, Matt and Mike, have a hard time agreeing on something in the moment. But...
No, we don't. Yeah, we do.
Well, maybe. I don't know. But thankfully, we talked about this episode's topic beforehand so that we're not going to completely improvise this. Today on the podcast, we are going to be talking about something called the 12-factor app. Now, when I say the word factor, Matt, what's the first thing that comes to your mind?
Math?
Yeah, same. I think of like, you know, what are the
Factorization.
factors? Yes, of 24 or something like that. Yeah. I also think of X factor, which is like that certain something that something is comprised of that gives it that zhuzh, but you can't really say what
Je
it
ne
is.
sais quoi.
Yeah. The mutikaputuja. I don't know, I just made up a language right now. I'm going to cut that out. That was horrible.
Probably should.
And by that, I mean, nothing is cutting out. You think I edit this podcast? What are you talking about?
I don't know. I don't listen to it.
Yeah, neither do I. I don't drink my own champagne, as the people at my work say. They don't say eat our own dog food. We drink our own champagne. Have you heard that before?
Is that because your product is so good?
Yes.
That you don't want to call it dog food?
And it's explicitly from the Champagne region of France, because otherwise it would just be sparkling software. Just jokes all over the place.
Do you have to build it there, or do you just like deploy it to Champagne?
Well, we continuously integrate and deploy it to Champagne.
Hey, now hold that thought. That's getting too relevant to the topic.
That is. Okay. Now that we got the hooby-joobies out, the 12-factor app. Yes. Okay. What is the 12-factor app? Well, it's a website at 12factor.net. And I think I'll just read the very first sentence because I think that sums it up. In the modern era, if we have any My Brother, and Me fans out there, software is commonly delivered as a service called web apps or software as a service. You may have heard it as SaaS. The 12-factor app is a methodology, that's an important word, for building software as a service apps that, and then there's a list of things. But basically, it's a model that you could use as a guideline when building your web app or any software really that is going to be used as a service of some sort. Normally deployed on a web, but could be deployed other ways. And there's 12 factors that we're planning on going through and discussing that seem kind of important and useful for your software development. For
sure. Yeah, there's some good advice in here. A lot of it, in my mind, is what I would consider common sense, but what I know from practice to not be. As my former stepmom, I guess, used to say, sense isn't all that common.
Yes. Well, and sense, I mean, when was the last time you actually dealt with literal change, like money, coins? I don't really deal with cents anymore.
That's not the type of sense I meant.
No, but it could be, because just roll with it, man.
You're supposed to say yes, and I have a bucket of coins in the front room on the rare occasion that I use cash, which is
I keep my coins rare. In like a burlap sack, and it's tied up with some string at the top, and there's a huge $ sign on the side. I just carry that around with me just in case I need it in any common sense scenarios that come up. I feel like that's one of those things that was probably invented by the media, and money was never actually carried around in burlap sacks with $ signs. That was just an easy...
Yeah, it's just fake news.
Yeah, but it's just an easy thing to show up visually that, like, hey, this is a container full of money.
Right. Like how poison has 3 X's on it. Alcohol has the 3 X's. Poison has the crossbones.
The crossbones, yeah. It's just...
Jolly Roger.
It's an indicator. Okay, why don't we jump in to the first of 12 factors. I think on today's episode, we're just going to go through the first 6, and then we'll hit the next 6 next time. So the 12-factor app, this methodology thing that we're about to talk about, created by this guy named Adam Wiggins, which just makes me think of
Ender's Game?
Yes, Ender's Game. Probably no relation. You may know him, people who are in the software development world, as the guy who started Heroku, which was, and maybe still is, a popular web app deployment place. I remember I first used it when I first got into Ruby on Rails, because normally when you think about deploying a web app back in the 00s or earlier, you open up like an FTP site, or you SSH to something, or you SCP something to the server where you need to put all the files that on your production system it's going to look at when somebody goes to your, blah, blah, blah.com. But this was like, no, you just type like Heroku deploy, and it takes your app and puts it on a server, and it was free, and everybody could see your wonderful web app that you worked on, and it was like mind-blowing at the time. Now this is like super common, but at the time it wasn't. So I don't, did you ever use Heroku, Matt? Or anything like that?
I used it like once in a tutorial, and then I think that app probably still lives somewhere, costing me, if not money, email space. I don't know. I'm sure I get spam about it.
Yes.
It's probably just like, hello world, and I don't know where it is.
Yes. Well, thank you, Adam Wiggins, I guess, for writing this 12-factor app. And now we will get into it. Codebase. Go for it.
Yes, and please thank your brother Andrew for saving the world. All right. Anyway, so Codebase. The first of the 12 factors is Codebase. One Codebase tracked in revision control. Many deploys. So basically what they're talking about there is to have your code in a version control system, something like Git, CVS, SVN, Mercurial. I don't know.
Whoa, okay, that was a little weird.
Great Scott. I mean, RCS, locally. No, don't use RCS. It's so old. But a version control system, and I think one of the points that they make in their article here is that it should be somewhat like a centralized revision control system, so that if I was working on something, you would also have access to it, as opposed to like RCS or whatever that's just local to your machine. Although for all I know, they've expanded that. It has been a couple of decades since I used that tool. Anyway, so everything in there, tracking all of your changes so that you can roll back to specific commits if you need, et cetera, et cetera. And there's in this specific example, and I think this is a good place to talk about how they distinguish what apps are and what they are specifically pertaining to in these articles. And they talk about here the code base and the app. There's always a 1-to-1 correlation between them. You don't have an app that is split across multiple repos. You don't have a repo that contains multiple apps. It's a 1-to-1 correlation, and I think that's good. They talk about if you have multiple code bases, then you have a distributed system. That tends to be what I work on. I don't work on a lot of what would typically be called an app, I guess, by their definition of it. And then the other part of it is that you're deploying the product, and you don't expect it to only be deployed once. So you can have like a local version that the developer's spinning up, maybe a staging area, and then production itself.
I agree. This is definitely an ideal thing that you should strive for. I think the interesting second bullet point where it says like multiple apps sharing the same code is a violation of 12-factor. The solution is to factor the shared code into libraries, which can be included through the dependency manager. And this makes me think of most of the things that I work on, be it a node project. You have your node modules where you're pulling in the dependencies for things. You're not, that code doesn't exist in multiple places. Like everybody should be using like that library in theory, because you don't want to reinvent the wheel. I mean, once again, this is an ideal that you're trying to shoot for. I think with the billions of people that exist and all the computers and such, you're going to get duplication, in general. But as far as your own code base, you should strive to do this, and you should not have like app stage, app dev, app prod. You should have things that can, when it's deployed to a specific place, that place knows its stage or prod and sets up any kind of thing that's specific to that deploy there. But that shouldn't be in your code if you can avoid it, because then it's a violation of this. So
Yeah, and they have several techniques, I think, scattered throughout some of the other factors that help address how to deal with some of those. And I think, like you said, this is an ideal. This is what people are shooting for. My read of this manifesto, I guess, that is 12factor.net, is that, they're talking about a very specific type of application. And so if you don't, if you're not doing exactly what they're talking about, your mileage may vary on how effective some of their factors are to factor into how you're writing your code.
Yeah, and I think this is a perfect segue actually into the second factor, because it kind of answers, well, how do I really do that solution? And that is, the second factor is dependencies, which is to explicitly declare and isolate dependencies. And it's more or less what I was talking about, how depending on your app's language and framework, Ruby, for example, has bundler, which deals with all the dependencies that your app might have. If you're using PHP and Symfony, Composer is another one. I already mentioned Node has Node modules. I mean, it
uses and you might use NPM or Yarn
right.
for that. Python has pip, right, as the package manager. And then there's the places of those things that those dependencies actually live in the cloud or whatever. If it's on an Artifactory instance or something else.
Yeah, actually, this factor goes even deeper than that. Not just should you isolate your dependencies for your specific app and its programming language, but if you use any kind of system tool, that should also not be assumed. And so if your app needs that kind of thing, there's no guarantee that those kinds of things will exist. And so they actually suggest if the app needs to shell out to a system tool, for example, curl, or if you're doing image stuff, ImageMagick, that tool should be vendored into the app, which, I mean, usually the programming language you have, it has some kind of library that talks to one of those system tools, and that's the kind of thing that you would vendor as a dependency rather than writing it into your app specifically. It should call out and say, give me this stuff, rather than it being inside.
Right. And then that would be something that is installed when you clone the repo,
right?
And you should be able to build it. It should install all those dependencies. I think they specifically call out you only need to have the programming language, and I think there was one other thing, but basically those and and the dependency manager,
right?
You have those two things, and then everything else should be installed. It doesn't assume the installation of. What was the one they used, ImageMagick or something like that, right? If you need to use that, it installs its own version of it, which is really important because one of the things I think they're really driving at in the 12-factor factors is that it is the concept of consistency. They want you to be able to consistently build and with no, exactly what you're getting. Deterministic builds all the time. Everything should be the same. If I go to a new machine and do the same build off the same commit hash, I should get the same result and no variance. Yeah. And I think that is a very, consistency for me is one of the key points of software development.
I totally agree. And this is something that you run into despite something like the 12-factor app methodology existing. I mean, obviously it's a guideline. It's not a requirement. You're not required to write software this way. And so lots of software doesn't work that way. And believe me, I've gone to plenty of open source projects that say, oh, just type this thing in and it will work. And I type that thing in and it does not work for various reasons. And it's usually a dependency that doesn't work, a dependency that has broken, for maybe it wasn't scoped to a specific version of that dependency, or that dependency doesn't, that version doesn't exist anymore on the internet, so it can't find it, or that specific tool was made to only work on a certain operating system and somehow doesn't work on mine or my version of my operating system. So yes, once again, this is a an ideal model to shoot for. But in the real world, unfortunately, a lot of dependency management is a huge thing. And you talked about NPM. Node is a huge ecosystem of dependencies just by itself, and it's changing constantly, and people are updating things constantly, and things break constantly because of those updates.
I had to deal with the support request last night.
Yeah.
Because a dependency changed.
Yes.
So, like somewhere deep down, and it changed in a way that was incompatible with the specific version of Node that I was using. And so at like midnight on a Saturday of a long weekend, I was working because someone else didn't do a good job of building their code.
Well, the thing is that this is talking about isolating and explicitly declaring the dependencies that you have for your app. But it does not talk about the dependencies that those dependencies need. And it's a rabbit hole that can go down very far, like you just said. And so that's...
Right. And that's where you would typically want to have like a lock file and stuff.
Yeah.
And they talk about some of that, I think. But even that's not always, you can only get down to so far of like what you can manage, and then something might get changed out from under you. You got one person that doesn't declare their dependency, in a fixed manner, and they declare it as, they use the caret or the tilde or whatever in the
semantic version.
Package management speak. Yeah. And then all of a sudden that trickles down and somebody made a dependency change that causes you to have to work late at night on a Saturday on a long weekend.
Honestly, thus far, obviously we're only on factor 2, but this one is so important, at least for the person who, when you're designing your software, this is very important to try to strive for this. But like you said, there's an ecosystem of millions of people and billions of software packages that you don't have control over, and you're kind of at the whim of the internet. And even if you have a lock file that says, I want this specific dependency, it still has to pull that down from the internet. And that may not exist when you go to do it. And thus it breaks for you, even though it doesn't break for your coworker or something like that. And so, real life gets
I also had to deal with that this week.
Right. It's like that thing that my mom always said, that when I started driving, like, it's not you that I'm worried about, honey. It's all the other drivers.
Yeah.
There you go. It's all the other dependencies.
And just like in driving, consistency is important. If you're a consistent and predictable driver, you're more safe.
Exactly.
But it's the other people you got to worry about.
Always.
Should we move on to 3?
Let's move on to 3.
Cool. Number 3 is config.
Yes.
Store config in the environment. I like this one. People don't do enough of this.
Yeah.
And sometimes they do it wrong when they do it.
Human beings.
So I'll just read the first little chunk here because it wraps everything up nicely. An app's config is everything that is likely to vary between deploys. So that's various deployment environments. What they have here is staging, production, developer environments, etc. And this includes, so that the things that might change or vary between deploys includes things like resource handles to the database or memcached or other backing services, credentials they use examples such as Amazon S3 or Twitter, and then per deploy values such as the canonical host name for the deploy, which is something that you often need to know. And what they're talking about specifically here is the strict separation of config from code, which is you do not hard code these values into your app. And I specifically am violating this in several of the apps that I have written because they don't have some of the requirements that a typical A12 factor app, as they call it, would need. They specifically recommend in here using environment variables as the place to store these changes. And that is a fairly common industry practice. If you deploy something onto you make an AWS Lambda function, you deploy it. One of the like just built-in sections is environment variables, so that you can put these kind of things in there. And you're like, this deploy has these environment variables, and then that way it can work well. Another good aspect of this, before I stop talking, is specifically around credentials. Having worked for a software security company for well over a decade, I am very concerned whenever I see credentials just written in plain text in the code anywhere. And keeping them in environment variables helps make it more difficult for someone to get the credentials to your system. Right. And you don't want them to have credentials to your system. Yeah. At least not those ones.
Yeah, writing like your AWS key or something like directly into the code. Yeah, that seems like an obvious thing that you shouldn't do. I think it's one of those things where when you're first working on something, you put it there because you just want it to work and you worry about the security later. That's not a security first thinking, but then you forget about it and then it gets committed and then bad stuff happens. Environment variables definitely, just so everybody understands what that means. It's like on your computer, like your local computer versus the development server versus the staging server versus the production server. These are all different computers or virtual computers, however you've got it set up, an instance in the cloud. They're a computer with an environment and they can have variables, and variables mean they change. So on each computer, it may be the same AWS_S3_ key, but it's going to have a different value depending on which server it's being deployed to. And that's something that is on the computer, which users would hopefully not have access to. And so you can write it in plain text on the server because they're not touching the server. They're touching your app, which touches the server. And so that's kind of what they're saying here. Like, yeah, and don't put it in the code, especially if it's a web app, because generally all the code that you put on the web is easily view sourced, unless you mangle it somehow. But obviously you can't mangle the key because it has to be what it is.
Even if it is obfuscated, obfuscation can be reversed, or reverse engineered at the very least. It can be, you can read things out. If you're ever storing anything, this is getting off topic a little bit, but if you're ever storing anything of particularly secret nature and you store it in memory, that can be seen.
Yeah.
And you got to watch out for that stuff.
I like the line they have in here. A litmus test for whether you've done this correctly is, could you make your code base open source at any moment and not worry about compromising your credentials? I think that's a perfect way. And because I've essentially been working in open source for a long time now, like all the code for all the pet projects I do generally go in GitHub. And so it's kind of like a check on me every time. Like, wait, this is going to go up on the internet where it will be saved forever. Am I okay with that? And you gotta check yourself before you wreck yourself.
Wreck yourself?
Yes, yeah. Exactly. So I think that's a great litmus test. Even if it's proprietary and you're never going to put it in open source, just think like you might. Yeah, could you? Yeah. And so I think that's a good way to think about it.
I always like to think, what if someone got access to my source code? And it's the same idea, right? I'm thinking of it in terms of a breach, but I like their more positive, pragmatic spin on it. What if you released this as open source?
Yeah. Could you right now?
I'd get sued.
And if you couldn't, then you're violating the third factor.
and you're not doing a good job with security either, which is orthogonal to this concept. But
and you are a bad person and should feel bad. No, not really. Yes. Well, maybe, but that's
all right, so that was 3. Shall we move on to 4?
Let's move on to 4. Ooh, this one has a pretty diagram. Okay, so number 4 is backing services. Treat backing services as attached resources. And the bolded TLDR of this is the code for a 12-factor app makes no distinction between local and third-party services. So basically, anything that is local to your code, the code you're running, versus a MySQL database that it's connected to, or a local SMTP server because your app sends email. Basically, these are all things that you should consider as resources in your app. Like they're not separate.
Your code isn't part of that, but
Right.
anything, if you're running a database locally on your machine for testing things out, how you reach out to that and how you reach out to the third-party service, how you define that, that is something that should be separated, and there should be no distinction. You're not running a different set of code in development that you are in production, basically,
Right,
to access these services.
And that's a good point about, I'm not sure if I'm stepping on a future factor because I don't remember them all off the top of my head, but it's sort of like the code to talk to the database for your app or the code that sends an email should be the same for all deploys. Now, whether that code talks to your local SQL or your SQLite database on your developer machine, or it talks to a remote MySQL server, that's neither here nor there. You should write it to where, and I think that is a future factor. So I'm going to stop talking about that. But yeah,
they do have something like that, but it is relevant here because there's significant overlap, and what they're saying is basically how you reach out to those backing services should be through something like a HTTP API.
Yeah.
You know, you should be using an API, and then you specify where that system is. You specify where that system is
in the config, perhaps
through your config. Yeah.
Which is separate from your code. The last line in this actually is a good one too. The current production. Oh, right. For example, if the app's database is misbehaving due to a hardware issue, the app's administrator might spin up a new database server restored from a recent backup. The current prod database could be detached and the new database attached, all without any code changes. So,
yeah, and sometimes you can even do that without a redeploy, depending on how your system's written.
Yeah.
Cool. Should we do, I think the next one will be number 5, and I feel like that'll be a good place to stop, and then we can do 7 in the next one where we won't be covering the intro.
Yeah,
All
go
right,
for
number
it.
5, build, release, run. This is effectively what I do all day. Make these things work. Strictly separate build and run stages. I think this one's really important. They break it down into a code base having 3 stages, not including writing code, which is its own thing. So if you look at your standard software development lifecycle, these are 3 pretty normal stages. In a common software development lifecycle, you will have these. You'll have the build stage, and its job is to convert or transform code usually from human readable source code to something. This would be like your compiler if you had a compiler, or it might be something that is, and that might not compile all the way down into, ones and zeros, but it might compile it down into machine code, which then the JVM reads, and if you're doing a Java app, etc. Might be the way that it's packaging up your files for, maybe it's putting in a Webpack or something for JavaScript, etc., etc. So that's the build stage. There's the release stage, which takes all of that and combines it with the config, and then that results in what they consider a release, which is the bundling of the build and the config so that it can be deployed and then into the last stage, which is the run stage. It can be run, also known as runtime, and that runs the app in the execution environment by launching some set of the app's processes against a selected release. They make it really clear in this particular factor. They say, I'll just read this bold section. The 12-factor app uses strict separation between the build, release, and run stages. It is very important in their minds, and mine, for that matter, to keep those separated.
You got to keep them.
Yep.
This methodology was written for web apps or software as a service, but like you said, this is something even for compiled apps or an embedded app. You have your code that's in your text editor that you're working on, and your dependency manifest that says, I need all these things. And then, you build it, and it goes, if it's a web app, often it will take, say, like your CSS or your JavaScript and maybe lint it, minimize it, combine it, take it from the as human readable as possible version to the most streamlined, efficient version that a web server will interpret. or if it's a. I mean, now, Matt, at this stage, the build stage, if you were building something compiled, like you were making like a Windows exe file, is that what you get at the end of the build stage? Is that exe, or is that the release stage?
I think the distinction between build and release is a little bit muddier when you're talking about like local executables, because you lose that. There's no real bundling of config,
Right,
and your build in that stage. So I would say it's the exe is the output of the build stage, and there really isn't a release stage when you're talking about this so much, unless. So at my last job, we had an app that got installed on people's machines, but one of the things there was it had a config file which was baked into its license. So you couldn't run the thing without a license, and then the license had config. So it was like there wasn't really a release stage, but if we wanted to send this application to people, they needed their license file, and then getting those two things together, that would be, I guess, a release.
Yeah.
Because that would be a strictly specific, anytime you run that combination, this version of the software and this version of the license, you should get these results every single time.
Yeah, this is a lot like it's sort of like version control. Like the release stage is kind of like a commit, and at that commit, you have built this particular set of code and paired it with this particular config. And as they say later down in the page, every release should always have a unique release ID, such as a timestamp of the release or an incrementing number like version 100. Although it's funny that they use V100 as their incrementing number, because that doesn't seem very semantic version-y to me.
It's not. It's just version-y.
Yeah. But yeah, it's
I
like,
much prefer semantic versioning.
yeah, well, and I swear they use that as a factor later. I'm actually kind of surprised. Anyway, yeah, it's like, so every time you do this thing, you build, release, and run, you're basically making a commit of releases. And so you can then say, oh, release, 2011-04-06 at time, it did this, and that caused the error, and not the one before, or not the one after. So that would be, if you use any open source software on GitHub, you might see that kind of thing. You see version releases, like this is when we built the software on this day at this time, this is the output. And so if you have issues with it, refer to that. And so that, we know exactly what your setup was. So this seems like a good thing for all software. I don't see any reason why you shouldn't do this. Can you think of any reason why, like, this is like overwrought? Because I would say most people, if they have any issues with this kind of methodology, it's that some of this is, the real world kills this. But I can't think of a way where it would ruin this.
I'm sure there are situations where your build and your run make sense to be together if you have a tool that is perhaps modifying its own source code somehow. If you get real deep into like actual AI, not this machine learning stuff, but like real AI, I could see, those probably need to be able to modify themselves, and then they don't, like, maybe in that kind of esoteric, weird scenario, you might not want to do this, but that's not an app. If you're writing an application, a standalone, I'm delivering this thing, people are going to use it. No, I don't think there's any good reason to not do this.
Okay, so far we've gotten through 5 factors. They all seem great. They all seem like things you should do with your app.
None of this is groundbreaking. None of this is...
but it's codified. I think that's what's important. It's codified in a thing that is well-written, that is easy to refer to. None of these factors, like the actual pages, are very long. So it's pretty grokkable. It's pretty grep-able, son. See what I did there with the words?
Yeah.
Okay. All right. Okay, I think now that I'm making terrible jokes, I think that's a good place to stop with the 12-factor app for now, but we'll come back later and talk about the other 7 ones. If you want to hear, first of all, thank you for joining us. And if you want to hear more about software development and such, you can find our other episodes at hackingthegrepson.com. And we try to put an episode out every other week on Wednesday. And until we speak to you again, We now return you to your regularly scheduled lives already in progress.